Good morning, everyone. Thank you for being here. My name is Roderick Randolph, and I'm a software engineer at Capital One. Today, I'm super excited to talk to you about creating a CI/CD pipeline for your Jenkins shared libraries. Before I go into talking about creating a pipeline, let me first begin with a typical situation. Let's imagine you're a software engineer, and you've been assigned a project to start building a new application. One of the requirements for that new application is to build a CI/CD pipeline. You want to automate the entire release process. Your obvious choice as a CI platform is to use Jenkins. You learn about Jenkins Pipeline as code features and ability to write a Jenkins file to define all your release stages. One of the very first stages in your new pipeline is to compile or build your application. So you begin to write your Jenkins file, and it starts to look something like this. Here, we have a typical build stage in a Jenkins file. We're building a Docker image. And then we're also doing a scan of the image for vulnerabilities. Then we're pushing that image up to a Docker registry. So this is just one stage of many stages in your Jenkins file. Months later, you finish this project. Months later, you move on to a new project. And this new project also requires a CI/CD pipeline. And you recall that, hey, I did this before, and I've already written most of the code. So let me copy-paste that Jenkins file into my new project, reusing the majority of the same code, but making some slight tweaks to change the name of the application. And then you move on to other projects, Project B, Project C, and you kind of rinse and repeat the same process, copying, pasting the same Jenkins file over and over. Some more time goes by, and you receive a company notification that says, hey, our company's moving from one registry to a brand new registry. And so now you realize you have to go through all of those pipeline scripts to replace the registry with this new registry. Now, multiply yourself by 100 engineers, all working on, say, 30-plus projects. Every engineer is implementing their own way of building a Docker image, pushing it to the registry, or they're copying and pasting the same Jenkins file over and over again. Now, blow that up to, say, you have 1,000 engineers, and they all doing the same thing, working on hundreds of projects, and there's no notion of reuse. And just imagine the number of pipelines and Jenkins files that are being developed and being duplicated over and over again. And if you're a team lead or engineering manager, you're like probably screaming and wondering, why is there so much duplication in the ecosystem? And your teams are spending so much time reinventing the wheel and implementing the same logic over and over again. And when these company-wide initiatives get pushed down, your engineers are spending a bunch of time refactoring or repeating the same code or updating the same code over and over, all over the place. And then you go yell at your engineer for violating the dry principle. So as an engineer, you go back to your code and you wonder, how can I refactor my Jenkins file so that I can minimize the amount of code duplication? Thankfully, there's a solution for that. Like most things in Jenkins, there's a plugin. With the Pipeline Share Groovy Libraries plugin, you can extend your pipeline scripts to use a shared library. Shared libraries makes it possible to share common reusable functions across multiple pipelines or Jenkins files. And creating a new shared library is pretty easy. You just create a new Git repository, and we create a directory called vars. And then inside that vars directory, we'll create a function called Docker build. And then inside that function, we'll abstract all of that logic that we had in our Jenkins file into our shared library. So now, when we need to make a change to, say, the registry, we have one place to make that change. Next, we'll register our repo with Jenkins, so Jenkins is aware that there is a new shared library. And then when we start building our Jenkins file, we'll say, We'll load our shared library that we registered with Jenkins, and then we call our brand spanking new Docker build function. So this is just one example of how you can make your code a lot cleaner, easier to read and understand, as well as reduce a lot of duplication in your pipelines. So now all you have to do is update all of your Jenkins files to use this library to reduce the duplication. Problem solved. Everyone can go home, no more code duplication. Life as a developer is awesome. But wait, I can change code in one place and have it applied everywhere. Sounds awesome, but what if something goes wrong or I introduce a critical bug? Now I have a single point of failure. If the library is broken, now all of my pipelines are broken. So the question is, how do I introduce a change into the shared library in such a way that it won't break everyone's pipeline? And that's what I hope to answer during my talk today. But before I start talking about the pipeline, let me set a little bit of context. At Capital One, we built an internal CI/CD framework, and it's customized to meet the need of our business. But one of the components of that framework is a shared library. I'm one of the maintainers of the framework as well as the shared library. We also have a dedicated teams of engineers working on developing new features and functionality into the library as well. We also have a culture of intersourcing, so we encourage developer teams, dev teams to contribute features by submitting pull requests. This model really enables us to increase the amount of code reuse across the company, minimize duplication, and save developers time getting new features to market faster. As part of our CI/CD framework, the shared library that we have is loaded automatically for dev teams, so they don't actually have to explicitly import it. We do this by taking advantage of Jenkins Enterprise feature called custom marker files. And so custom marker files, we can instruct Jenkins to execute a custom script, what we call a bootstrap script, prior to running the actual dev team's Jenkins file. So this is what that bootstrap looks like. Here, we're calling a function called getLibraryVersion, and the purpose of this function is to determine which version of the library to load. Then we load the library using Jenkins built-in library function. So this will basically check out the code from the Git repo, switch to that branch or tag or Git SHA, and then expose those functions into the Jenkins file. And then finally, we load the actual developer's Jenkins file. So having a bootstrap script like this helps us to, one, look for deprecated features that teams may be using in their pipelines, allow us to add additional tracking information or monitoring to detect errors or just general adoption to gain adoption numbers. So this bootstrap script is maintained by our core team, and we control the version that gets loaded. So this brings up an ancient old question of to pin or not to pin my versions, right? There's pros and cons on both sides of the debate. The main reason why we dynamically control the version is to ensure pipelines stay up to date and are continuously getting the latest library changes. So there's a number of benefits to this. One, we can quickly roll out changes, bug fixes, and fix other major issues fairly quickly. So next time a team runs their pipeline, they're automatically getting those changes. They don't have to wait weeks or months to get those patches. Dev teams are able to take advantage of the new features immediately with very little effort. And it reduces the painful upgrade headaches that we all love when our versions gets out of date, right? So we all experience the pain of being on a version and never upgrading, And then when it comes time to actually upgrade, we realize that there's so much work to do that we keep pushing it off and keep pushing it off. So with this approach, we eliminate that headache by making sure everyone is continuously being upgraded at the same time. Here's a snapshot of the volume of releases happening against our shared library. As you can see, we perform multiple releases every day. Every PR that gets reviewed, tested, approved, merged, becomes a brand new release. So you may be asking yourself, why do we release so frequently? And the answer is speed to market. Our customers, which are our internal developers, they move fast. They constantly want new features, bug fixes, enhancements to be made available. If we're unable to deliver quickly for developers, then that slows down their velocity to launch new features for the business. And if the business is slow, then we're slow to launch new features for our external customers. And if we're slow to launch features for our external customers, then we start losing our competitive edge. And I think you kind of see where I'm going with that. So there's a direct correlation between velocity of release and how quickly we're able to react to change. Now, this velocity doesn't come without some trade-offs. It requires us to be very disciplined in our coding, review, and release process. So here are a couple of guiding principles that we follow when making changes to our shared library. One, design clean API interfaces. This means being very thoughtful about each function, make sure each function has a clear purpose, we understand its inputs, the expected outputs, and we establish some standards and naming conventions for those variables. Remember, we're creating a contract between our users and our functions. And this leads into the second point, always maintain backwards compatibility. We leverage feature toggles. We seamlessly migrate users from one feature to another, or one function to the other. So if we introduce a new capability and we're deprecating something old, we're seamlessly migrate users from one function to the next. And if we absolutely need to break the contract, we implement deprecation notices and communicate to give users plenty of time to update their scripts. And last, we keep changes small and digestible. So the more lines of code that's changing per PR, the longer it takes, one, to get reviewed, approved, but two, the greater the risk that change could introduce a bug or incident for our users. So it's easy to add code. Deleting code is easy if it's not being used, but modifying existing code is harder and requires much deeper code review. So keep changes small and digestible. So to drive home the point of backwards compatibility, let's say the default behavior of our Docker build function is to push images to Docker Hub. And later we're told we need to move to an internal private registry, say Artifactory. While we could change the default behavior under the covers for our users, the change could cause problems for users who aren't ready to actually make that switch. So instead of changing the default behavior, we'll add a new feature flag to allow users that are ready to opt into Artifactory to start using that functionality sooner. And then after some time, when the majority of our users have migrated, we'll safely switch the default to be Artifactory so that the flag is no longer required. This is a much better approach to maintaining multiple versions of your library and having to backport changes to older versions when needed. All right, so I'm going to move on to the pipeline, but before I do that, quickly want to talk about our branching strategy. So we use GitHub Flow as for our branching strategy. So the idea here is developer or someone who wants to contribute a change will create a feature branch, commit some changes onto that feature branch, open up a PR. When that PR is opened, kicks off the pipeline. The PR then gets some feedback from the maintainers, and then once approved, the PR is merged into master, and a new version is released. All right, so let's talk about the actual pipeline itself. Let's begin with the build stage. So to build our shared library, we need a build script. And here we're creating a basic Gradle script. We're defining our plugins, our source directories, and our dependencies. Fairly straightforward. And we'll add our build stage to our Jenkins file. And it's basically we're just going to compile the Groovy code just to make sure it's valid syntax. We can also add linting. We can also do static code analysis. I've left that out for the purposes of this talk. One thing to note, we don't need to generate a jar file. So Jenkins will actually check out the GitHub repository and run it dynamically on the fly. And so that's our build process, our build stage. Let's now move on to the test stage. So going back to our Docker build function that I showed earlier, we want to write a unit test to confirm that the function will work as expected. In order to do this, we need a testing framework that helps us stub out a lot of the Jenkins Pipeline DSL, such as the shell commands, the retry, the with credentials, the nodes, and so forth. And there's an open source project called Jenkins Pipeline Unit Testing framework that we can use. We're also using this for our pipeline as well. And to use it, all we need to do is build a mock Jenkins file. So we're going to mock out what a Jenkins file will look like and call our Docker build function the custom function that we've created. So now we actually write the unit test. And this is what that unit test will look like. So we're going to test to see if the function will actually push to a registry. First thing we'll do is we load up our mock Jenkins file that we created on the previous slide. We'll print the call stack. So these functions are built into the pipeline unit framework itself. So it makes it really easy to troubleshoot when you're trying to debug and figure out whether or not a method was actually invoked. Next, we'll do an assertion to say, hey, did the Docker push command, would that command be invoked? And will it have the correct arguments? So we can actually test to say, hey, does the URL of that Docker image have the correct registry? And then the last step here is to just validate that the job will run successfully. So this is the output of what that looks like. It's basically a call stack of all the functions that were called, and we can check here and see that, yes, Docker push was invoked. Now all we have to do is add this test to our pipeline. So we're going to add a call to run our Gradle test functionality. All right, so now you may be wondering, what about integration testing or end-to-end tests? And to perform integration tests, we actually need to run our pipeline or Jenkins file on Jenkins. And note that Jenkins Groovy DSL is not the same as plain old Groovy. So we'll want to find a way to run our actual library methods on Jenkins. So one of the things that we do at Capital One is we have our shared library pipeline run against itself. And it's as simple as telling the library to load the current branch. So if I'm developing on a feature branch or on a PR branch, load that current branch. And then we call a function that's part of our library. So Gradle build is actually a function in our pipeline library. And you can extend this even further by executing an actual Jenkins file with library functions against the library itself. So this helps validate that the library functions will actually run on Jenkins. So you're actually running those functions on Jenkins. And the one thing to note, though, if you have any back-end calls, you may need to stub those out if you don't want those actual calls to be made. Read trusted is a built-in feature of Jenkins. So I don't know about you, but like, right? Mind blown. The library's loading against itself, doing some crazy stuff. So this is really awesome. All right, so let's move on to the release stage. We've now tested our pipeline. We feel confident. We've run hundreds and hundreds and hundreds of tests. We're now ready to release. This release stage is only executed on the master branch once everything's been reviewed and approved. So to create a release, we'll just create a GitHub release. And when we create a GitHub release, it creates a marker that says, hey, this was released. This is a tag that's associated with that release. And if we need to find a tag associated with that release, we can make a simple GitHub API call. And so going back to our Bootstrap script, if we want to find what the latest version is, we have this Git library version, our custom function that we wrote. And basically, it's going to call GitHub API and say, hey, tell me what's the tag associated with that latest release. And so kind of coming back to our Bootstrap script here, Git library function, Git library version gets replaced with the actual tag name. Remember, latest is not an actual tag. Latest is just a marker in GitHub. And so we want to know what the actual tag name is, because if we were to call the library function without the actual, if we call the library function with latest, it'll be like, I don't know what latest is. So we actually need to go find that actual tag name. Yes, I will talk about that. So let's take a higher picture, a look at the release process if we were to use this technique. So we start off with 010 as the latest. Every time we merge a change into master, that version becomes, or that creates a new release, 01.0, 011, that becomes latest, and we repeat this going forward. So this is great, right? Now we have a way of tracking what the latest version is. But the problem here is everyone gets the latest version at the same time. What if we want to roll out the changes to a small population first before we roll it out to everyone? And this isn't a new concept. It's called Canary release or Canary deployment. So how can we do this with Jenkins shared library? Well, at Capital One, we have a fleet of Jenkins instances, masters. They all serve different parts of the business. And to implement a Canary deployment, all we have to do is identify which instances have the most users, and then select which instances we want to put into that Canary population. So here we have a 70-30 split. So 30% of our users will get the latest or the Canary version, while 70% will get the previous or the stable, what we call the stable version of the functionality. Now, if your company doesn't have multiple Jenkins instances, you could be a little bit creative. You could say, look at my job names. If the job starts with letter A through F, they're Canary. Everyone else is a stable. Just make sure you use something that's kind of consistent, because you don't want your pipelines, your developer pipelines to start flip-flopping back and forth between stable and latest. You want them, if they're on stable, to stay on stable. If they're on latest, to continue to stay on latest. All right, so pulling back up again, let's see what this release process looks like now. So everyone starts on the same version, 010. We release a new PR gets merged to create 011. we launch that to 30% of our population, and then the remaining stays on the previous version. So we repeat this again. Every time we make a release, latest goes to 30%, and then everyone else gets stable. Stable is a tag that we've created. So we built some functionality around that in our Gradle script to create this tag and promote it every time there is a release. All right, so coming back to our Bootstrap script, we now have a way of getting we want to get the stable version. We make a slight tweak to our code that says, hey, if the Jenkins URL contains our Canary Jenkins instance, then we'll use the latest tag. Otherwise, we'll use the stable. So pretty straightforward implementation here. All right, so we've released our code. Everything looks good. The final step in our pipeline is the rollback checkpoint. This is where we're going to pause the pipeline and monitor for potential issues in case we need to roll back. So to pause the pipeline, we have an input prompt that gives us the option to roll back if we want to, and then we also wrap it in a timeout closure so that the prompt doesn't stay out there forever. You can adjust this however long you want, an hour, 2 hours, a day, multiple days. It's really up to you how you want your rollback strategy to work. But for this purpose, let's assume it's 4 hours. This is just a screenshot of what that prompt looks like in Jenkins Blue Ocean. So during this 4-hour window, we want to monitor the application. We want to monitor how pipelines are running with this new version. So we use Datadog to collect metrics. So every time a pipeline runs, we send metrics to Datadog that says, hey, this pipeline was executed. These are the tags that were, or these are some of the common attributes that were captured, the job status, the version of the library, the name of the exception. So all of these helps us determine whether or not there's a problem. There is a Datadog Jenkins plugin, but the last time I checked, it only supports Datadog events, not metrics. And there isn't a pipeline DSL function that you can use out of the box, but using HTTP requests is a quick and easy way to make API calls. So next, we'll set up a Datadog monitor to look for unusual spikes and errors. There are a number of exceptions that can be thrown when a pipeline runs. The most common exception is the Hudson abort exception. And don't take abort exception to mean that they aborted a job. It just means that the job failed or stopped running for various reasons. It could be the developer's unit test failed, or their integration test failed, or they had the wrong syntax in their Docker file that caused the pipeline to halt. And so while we can't always attribute a pipeline failure to a change in a shared library, we can make some elimination, process elimination by saying, hey, was there a new version just released and was there a spike in exceptions? Then, hey, we need to look into this issue fairly quickly. Now, unfortunately, monitoring tools we can't always detect issues with monitoring tools. So sometimes we actually need to listen to our actual users. So we have a developer Slack channel where users of our CI/CD framework are able to hang out, ask questions, engage with us, engage with the community, and occasionally a developer may post a message indicating that their pipeline job is failing and could use some help from someone in the community or on our core team. And then others in the channel will react and say, hey, I'm experiencing that same issue, and just things need some attention. And given our Slack channel is really large, there's a lot of people in it, a lot of threads, we can't kind of watch it 24/7. So we've enhanced our in-house Slack bot to monitor the channel for posts, and it will send a notification to our core channel and says, hey, this thread is getting a lot of reactions. Maybe it's time for someone to take a look to see what's going on. And if there's been a release, we can assume or make some assumptions that maybe that release went bad and we need to roll back. So coming back to our release process, or release illustration, let's assume we've made a release, it went out to 30% of our user population, and we pause the pipeline for 4 hours, let things bake for a while, and during this period, we're monitoring, we're looking out for Slack bots to tell us if there's an issue. So if there's no issues, we allow the PR to proceed, latest moves forward, wait 4 hours. But what if version 0.1.2 catches on fire, right? There's an issue. We need to roll back. Well, since we've been using GitHub releases, all we have to do is delete the release. Now, when we delete the release, we're not deleting a tag, we're just deleting the release. When we delete the release, it moves the latest marker to the previous version. So built into GitHub, it'll internally move the latest marker back to the previous release. So now, coming back to our illustration, latest goes back to the previous version. And when this happens, we have Jenkins send our core team a notification that, hey, something happened, something went wrong. We need all eyes on glass to fix the issue. So now, even though we roll back and we've minimized the impact on our actual customers, master is still in a bad state. And it could take, depending on how long your pipeline to execute, if you want to revert or you want to roll out a hotfix, it's going to take however long it takes to run your pipeline to get that fix out. So the quickest way to minimize that impact is to delete the GitHub release, and the next time a user runs their pipeline, they're on that previous version. So for fun, let's assume that stable is also on fire, and we need to do something about that. Well, again, we'll delete the GitHub release. That moves latest back, and then we have a custom Gradle script that will move stable back to its previous version as well. So obviously, you want to minimize the number of times you do rollbacks, because if you're constantly rolling back, that means there's something wrong with either your testing strategy or just there's something that we need to do to kind of minimize those issues. So one of the things that we do best practice is when there's an issue, we write a test to confirm it, to recreate it, and then implement a fix so that the next time we run our pipeline, it goes to that regression suite. So we don't reintroduce that bug again. So now we want to move forward. Our next release will include a fix. And then we move latest to that fix, test it out on our Canary population first, let it bake for 4 hours. And then from here, you can have stable promote to that version immediately, or you could wait to the next release to move stable to that version. So it's kind of up to you how you want to implement that. So that's our CI/CD pipeline at a quick, rapid speed. In closing, today you learned the importance of using Jenkins shared libraries to reduce code duplication and how it can save your developers time. You learn how to create a CI/CD pipeline for your shared libraries to increase your confidence when releasing new code. You also learn strategies for how to release, monitor, and quickly roll back changes so that it minimizes the impact on your end users while still allowing you to release multiple times per day. But more importantly than all of that, I hope I've inspired you to think and apply creative ways to increase the velocity by which your teams are shipping software. The opportunity cost of software sitting and waiting to be shipped is too high. No software should be exempt from having a continuous delivery pipeline with multiple releases per day. No, not even Jenkins shared libraries. And with that, I'll reintroduce myself. I'm a distinguished engineer at Capital One. I'm part of a team focusing on reimagining the software delivery experience for our engineers to make it simple and effortless. And as you can probably tell, I love CI/CD. I really love the ability to ship software quickly, safely, and with really high quality. So if you share the same passion as I do and interested in working at Capital One, please come chat with me or connect with me on LinkedIn. And with that, thank you. I have some time for a couple questions. Green shirt. So the Bootstrap script there's actually a feature in Jenkins. Of course, you need to have the enterprise version. Basically, you set a custom marker file that says, hey, when it's scanning your GitHub repository and it finds a Jenkins file, it says, hey, I found a Jenkins file. Instead of running their Jenkins file immediately, run this other script, and then that other script can then run the actual pipeline script. Yes, so part of our framework, we automatically set all that up for our users, so they don't actually need to configure any of that in Jenkins. Yes, the question is, will these slides be available? And yes, they will. I will post them. I will post them on the DevOps Jenkins World site as well as speaker deck or what have you. You should have access to it. Yep.
Do you use like development and test version of Jenkins and promote these up through for your testing internally for the scripts?
The question is, do we use test Jenkins to promote? Yes, we do have a test Jenkins instance, but that's usually used for kind of major changes to Jenkins or the plugins or what have you. For our pipeline library, we load that directly into production. Gentleman in the back. So the question is, can you run Jenkins locally? You could, in theory, do that. We aren't doing that right now. We actually want to. One of the challenges of doing that locally is you have to recreate basically what you have, what your production environment looks like locally, like including all the plugins. Like it needs to be an exact match. What we end up doing is we test like directly on the actual production at Jenkins, like through feature branching or through our QA environment. But yeah, you could do it. We don't actually do that. Yeah, so pipelines are reliant on Jenkins being available. If there's a major issue in production, we need to recreate production. There are ways to deploy code directly without going through a full CI/CD pipeline. But you're basically you're taking code that was already in production and basically rebuilding production. You're not actually taking it through a pipeline. But if you're building new software and you're trying to ship that, yes, that's dependent on Jenkins being available. Yes, exactly. Burgundy. Yes, yes. That's you can't really write any kind of tests to assert that, hey, did this? You could do some. You could test, hey, if I'm building a Docker image and pushing it, hey, did that image? You could do assertions that, hey, is that image actually in Artifactory or wherever you're pushing it to? But in most cases, we're just validating it. Hey, did it successfully execute? There weren't any kind of CPS kind of issues with that code? Yes. So we do provide templates for our dev teams to use. Obviously, they have the ability to kind of adjust those and tweak them. So it is challenging to make sure that when we introduce changes that things are fully backwards compatible. And so part of that is, rolling it out to 30%, seeing what happens, and if something is bad, roll it back. Otherwise, keep moving forward. Yeah, yeah. So we only have one shared library. This is the shared library that's used across all of our pipelines. Yes?
So the pipeline that runs, that deploys the shared pipeline, it does the git tagging and everything, right? So is it how do you know which of the objects or what have you to increment? Is it always just the smallest one, or?
I'm not sure I follow the question.
So you have version 1.0.0.
Yes.
Increment that. How do you know which one to increment? How does the pipeline know which one to increment?
Oh, you mean the major minor build? Oh, yes. So we use an open source project called Git version. It basically looks at your tags and automatically bumps versions for you. It's built for Windows or Microsoft, but there's a Docker image, so we just basically reuse that Docker image in our pipeline. And then when you want to bump the major or minor version, you add a certain keyword to your commit messages, and it knows to bump it. So it's really nice. Automates the tagging process for us.
How are you populating the metrics? You're using Jenkins metrics plugin, or you're populating it via your shared library?
The metrics itself is part of our library. So in that bootstrap script that I showed earlier, I didn't show the full script, but in there we're also shipping metrics to Datadog using the HTTP requests function that's built into Jenkins.
What's the help is for the library and the performance of work?
Yes.
And what if you make the library huge?
Yes.
Actually affect the performance of the pipeline. And what if we decide to load it in a folder for all the users that they use this folder instead of actually letting them decide to load it or not?
Yes, so the question is, what if does the pipeline, the fact that it's checking out on every execution, does that have a performance impact? And then what if a user doesn't want the library? So that is a great question. I think that every time a pipeline runs, Jenkins under the covers will just check out the repo. One of the things that we do is we tell Jenkins not to clone the full history, Git history, only do a shallow clone of the first commit, so it reduces this footprint on the master. So that's one way to make sure that you're utilizing space efficiently. And then the other question you had around folders. If someone doesn't want the pipeline. So unfortunately, we are everyone's moving to the same pipeline framework, and so part of teams building new pipelines or building their pipelines, they're going to get the shared libraries by default. So the assumption is that they will need it and provide it for them by default versus, hey, do you need it or not need it? You just get it by default. The gentleman in the back.
I was wondering about the 30%. Are you always using the same 30%? And how do you, like, is that in the code you randomly choose the people, or,
Yeah. It's the same 30%. So one of the reasons for that is to make sure they're getting a consistent experience, because we don't want them to, and then the other, the way, and I mentioned this earlier, is the way we determine that 30% is based on the size of the Jenkins master, like a number of users are on there. We just draw a line that says, hey, if they're below this number, then yeah, you're in the Canary population. If you're above, you're in the stable. Yes, I have time for one more. I'm sorry? Where did we store the 30? So we actually store it in a configuration file. So we actually do another GitHub call to read our config file on the fly. If you don't want to have that extra network call, you could just embed it into your Bootstrap script. So it's up to you. Depending on how often it changes, you may want a config file. If not, just embed it into your code. All right, thank you, everyone.